Hello, welcome back to Java programming. In this video, we're going to talk about variables. We're going to talk about variable types, different expressions that we can use using mathematical operators, and we'll talk a little bit about how to do some basic input and output with the user. So that will be a bit more complicated because it is Java. We're going to have to create a scanner object for it, but we'll get to there when we get to there. Let's just start out with what is a variable. So a variable is really just a name that we give to a memory location. So somewhere in your RAM, you've got some memory that's associated with your program that's been assigned to it. It's actually a big dynamic page thing, but so when I say memory location, it's not determined by a memory address. It's actually a memory offset based on the memory that was assigned to you. Regardless, all that's more complicated than what you need. That name that we create for the variable is just a location in memory. And so we can put a different value into that location. That value can change, which is why we call it a variable. And it's just set up so that we can solve dynamic problems, right? Like if you think about, I want to make a purchase online and I've got a few different options. Like I don't know how much to charge you until you decide on the option. So based on your option, I can change that variable to be whatever the cost of your particular option is. Are you subscribing for 6 weeks? Are you subscribing for 6 months or for a full year, right? I don't know. Depends on what you select. Once you select it, I can change the value in that variable. And then I can use that value in calculations to figure out how much I should charge you. That's the idea behind variables. We want to have a place to store a bit of information so that we can solve a problem. With most languages, the computer needs to know, the compiler I should really say, needs to know what type of variable is going to be stored at that location so that we can interpret it properly. And that's because everything is binary code, right? The integer 42 is represented with a set of ones and zeros. Well, that exact same set of ones and zeros, if I interpret it as a character, becomes the asterisk character, right? At least in basic ASCII. In UTF-8, it would be more complicated, right? It would be a larger number than 42 for sure. But the idea is that, I need to know how to interpret it. I also need to know how much space I should allocate for that variable because different types take up different amounts of bytes, right? Integers take up 4 bytes, whereas something like a double, which is a floating point type number, and we'll get to this in a second, that can hold a little bit more information, takes up 8. A Boolean value only takes up 1 byte. In fact, it could probably take less if we did bitwise operations, but the Boolean type, and just based on the addressing, byte is sort of the smallest thing we can use. So I need to know how big that area is. So it's at this memory location, and it's going to be 4 bytes worth of information versus 8 bytes versus 16 bytes or 1 byte. So that I know kind of how to interpret it and how much I should be reading. And so when we create variables, we have to give it a name. We also have to give it the type. We can also set a value immediately if we want to, but we'll get to how do we actually use them after we talk about types. So here are some of our first types of variables we can create. All of these have something in common. They all hold what we would call whole numbers, right? Integers. So 1, 2, 3, negative 42, right? No decimal points, no places after a decimal point. They have to be whole numbers, integers. And so we call them sort of integer types. In fact, the most common of these is the int, which is 4 bytes representing an integer. That is sort of your default, what you would actually use. The only difference between them is how much memory you dedicate to storing information, because the way binary works is sort of exponential, right? As you add, bytes or individual bits, a byte can only hold numbers between like negative 127 and positive 128, whereas an int can hold up to 32 million to negative 32 million-ish, right? Longs can hold even more than that. So basically these types are kind of just used to hold whole numbers. Anything where you don't need a decimal point, you would use probably an int. If you have a really big number, maybe a long. Now the literals that you would use, so like if you're actually typing in an integer, like you want to set a value to a particular value, and so you're trying to express that value as a literal in your program, you could use 42, You could use 4200, but you can't put commas in there. Anything with a comma, the computer just doesn't know what to do with commas. Some modern languages like Swift overcome this, but it's a little less human readable, but no commas in your numbers. The other thing is don't put in decimal points. That's technically a double type. Now, there may be an implicit conversion that makes it okay depending on how you're using it, but just know that strictly speaking, 4200.00, even though has the same value as 4200, and if you were to put it into an integer, it wouldn't, you wouldn't lose any information. You're still doing an implicit conversion. That literal is a double type literal. What do I mean by double? So these are the two types that you're going to use to hold decimal numbers, right? Anything with a decimal point and some numbers after the decimal point. The reason that these are separate in a computer is that the way your processor works is that for it to do any math, right, it has to have two numbers or two values, right, in registers. And then it sends those values down particular pathways in the ALU, the arithmetic logic unit, to achieve that procedure, right? If you want to add, there's a place to send add. If you want to subtract, there's a place to send subtract. Although in earlier processors, they used to actually just flip the sign of the second number and send it through the add. But we don't have to worry about that. Technically, there was no multiplication pathway either. You just used the addition pathway multiple times. It was just more efficient to make chips that way. Now we have a multiplication pathway. Regardless, the pathway that you use to add two binary numbers that represent integers together is different than the one that you use for floating point, and that's because of the way floating point is represented. Floating point is in binary represented as sort of a scientific notation. It's a number with a exponent. So they call it a mantissa and an exponent. So 3.4 times 10 to the negative seventh, right? I'm just going to store the 3.4 and the negative seventh, right? Or negative 7, right? Those two numbers I can use to create a floating point. It's called floating point because effectively by doing that, you can make the decimal point float wherever you want. You could have 32.36798745, or you could have a very large number with not very many places after the decimal point. You can kind of decide, do you want a larger overall number with not much precision, or do you want a smaller number with greater precision? And all of that requires different pathways in the ALU to perform basic operations on these types of numbers. So they're a different type. The two types that we have are float and double. Floats use 4 bytes of memory, double use 8 bytes of memory, and the default is double. And that's because the way we represent stuff in binary is not exactly perfect. And so you can end up with some basic rounding errors when doing operations on floating point type numbers. I'll even say floating point type numbers, although I'll use doubles for the most part. I might use floats every once in a while just because this is an educational class, but once you get to industry, it's almost always doubles, even though it uses more memory, and you would think it would be less efficient. The literals for floating point in Java are different than in some other languages. So if I just put 42.0, that is a literal of type double, right? That is a double literal because double is the default. If I wanted to use a float and I was going to create a literal with it, I'd actually have to put an F at the end of it. The F at the end makes that a float. If I do just 42, that's an integer. Although practically I can take an integer and put it into a double with an implicit conversion that the compiler does for you. It would be fine, you wouldn't lose any information. And that's really the key when it comes to these conversion things where you're accidentally using two different types. Is that you don't want to lose information. I don't want to create an integer and then set its value to 42.174 because I'm going to lose that 0.174. It's going to get truncated, just sliced right off, and I'll just end up with a value of 42. I'm losing information, which might be a bad thing, might be a good thing. You just need to know what you're doing, right? You can also represent these with scientific notation since that's kind of where they come from. Except instead of doing times 10 to the you just put an E. It can be capital, can be lowercase, doesn't matter. And then that changes the meaning of what it is you're doing. But those literals work too. Although in practice, I never use them. So there are also non-numeric types, and I've mentioned that sort of earlier, right? That it depends how we interpret that binary. If the binary 42 is an integer, well then it represents 42. If I'm using it as a character, the char type, well then a char, it would be the asterisk character, right? The wildcard character. It varies kind of based on what it is. So if you create a variable of type char, then we know that we're going to interpret it as a character. Characters have a little bit of weirdness because you're just going from a number to something else. So char a equals 66, Java is actually going to provide an implicit conversion to make that a character with the ASCII code or the Unicode 66, right? It's, I think, capital A, right? It's something, right? Whatever you print out, it's like, I'm actually getting a character from this number. In practice, don't do this. This is like tricky weirdness, but not very clear what you're trying to do. If you want to assign a character, assign it to a actual character using single quotes around it. And so here you'll see that 5 is an integer, right? That's a literal that I can actually do math on, right? It's an actual number. 5 in single quotes is the literal for a character. I cannot do math on that. That is the character that represents 5, which incidentally in ASCII does not have the value 5. It has some other value. If I were designing ASCII, I would have made it the same. 5.0 is a double, which again you can do math on. And then 5.0 in double quotes is a string of characters, which you cannot do math on, right? Unless you do some conversions, which are always possible. There's a lot of functions to do that sort of stuff, but just know that there's a difference. If you're putting quotes around things, single or double, those are no longer numbers. Those are characters that you cannot do math on. Without the quotes, those are actual numbers. So what about strings? As it turns out, string is not really a primitive type in Java. String is a class. You create objects of type string. Here, I'm creating an object of type string and setting it to the string literal hello world. In effect, though, you can think of, and so this is just this particular slide is saying, from a technical perspective, what I'm doing is I'm creating an object containing a string of characters that I'm putting into memory, and the address of that memory object is the first character. But you don't have to worry about, and by the way, there's nerd glasses on that because this will never be on a test. This will never be on a quiz. At this point, I don't care. I just want you to be able to use strings. But you can practically think of strings, at least for right now, as variables, right? They're just of the string type. The only thing that's going to differentiate them is that the string has a capital S because it's technically a class. But other than that, you can think of it as just a regular type. The only thing that kind of changes, though, because it is a class, and because I'm actually creating not a variable S, I'm creating an object S, is that that object S, I can actually call methods on that object. In other words, that object has sort of buttons on it that I can use to do different things. For instance, I could say, hey, I've got a string called name. What's the name? What's the length of that name, right? I can push that button. It'll return a value for me. So here I'm setting the variable name, technically the object name, to my name, right? Brian Baker. And then I'm saying int size equals name.length. So what's the length of the name? Well, in this case, size would have the value of 11 because there are 11 characters in my name. And I know what you're thinking, there are only 10 letters in Brian Baker, but remember that space in the middle is still a character. It's just one you can't see. It's kind of the whole purpose of it, to not be there, to create no letter, right? To separate my first and last name. But it's still a character, so that string has 11 characters in it. But you can use length to get the number of characters in a string. You can also do char at. So this will tell me what letter is at a particular position within the string. You probably won't need this, but you know, I'll throw it out that you can. Char at 3 is actually going to give me the letter A And that's a weird thing that will make more sense when we start talking about arrays and array lists, but that's because we always index things in computer science starting at 0. So the capital B is at index 0, lowercase r index 1, I index 2, lowercase a is index 3. It's actually the 4th character in my name. Eventually, you'll get used to that whole starting at 0 thing. I promise. It just takes a while. To upper will take a string and convert all of the characters to uppercase. To lower does the exact same thing, but to lowercase. These are often really helpful when trying to compare two strings because, I mean, you know, I'm technically Gen X, right? I capitalize words. If you're millennial, you don't. You just, everything's lowercase. I'm completely, you know, generalizing here. But like if I and a millennial type the same word, we might not have the same case. So it's good to just be able to compare apples to apples, convert everything to either lowercase or uppercase, and then compare it to see if it's the same word. Sometimes it can be helpful. This last type is the last type we're going to talk about. We won't actually go into much with it. We will very, very soon, but it's a Boolean type. And so a Boolean type uses 1 byte. It can have a value of either true or false, and that's it. It can only have one of two values. And the reason for this is that if I have 2 plus 3, that expression would evaluate to an integer, right? 5, you know that. 2.2 plus 3.3, right? 2.2 plus 3.3 would evaluate to one of the floating point types, right? Probably a double. 5.5, right? The result is a different type. There are some operators that when you use them, they don't give you a numeric value. They give you a logical value. So 2 less than 3 gives you the value of true because 2 is indeed less than 3. So that operator doesn't give you a numeric type, it gives you a Boolean type, true or false. We actually use them a lot when it comes to decision making, which is why we're going to talk about Booleans when we get to branches and the all-important if statement. But those are the basic types you're going to need for this class. All right, so now let's actually use some of these ideas in Java as we're actually trying to build a program. So let's say I want to create a program that will calculate the, I don't know, the tip that you need when you go to a restaurant. All right, so to do this, I'm going to need to create some variables, right? There's a few things I'm going to need. And so the way that I create a variable and give it a straight value would be to start with the type. So here I've created a new project using that standard template, and I'm now inside the main function because that's the first function that's going to get called. So this is where the action is going to start. And I'm going to start with creating a variable. Now, money is generally expressed as a double, right? It has a decimal point with some change at the end, or some cents, right? So I'm going to use the double type to represent the amount that I owe for my bill, right, for this tip. So now I've got a double. I'm going to choose to name it something. I have to call it something. Bill amount. Now, this probably sort of brings us to some conventions in Java. When I create a variable, I use what's called camel case. So camel case, in fact, I'm going to put the semicolon right here because that's actually all I need to do to create a variable. Give it a type and a name. So bill amount is 2 words. It starts with a lowercase, but then when the new word begins, I use an uppercase to start the new word. Bill amount for meal, I could add on additional words. If I added on a whole bunch of words, that would be very Apple style. Some of their variable names, I swear, take up like half a page. But regardless, bill amount, I think, is going to be enough for us, right? It's the amount of the bill, the charge, honestly, naming things is the hardest part of computer science. So double bill amount. Now I can just put a semicolon and boom, I've created the variable. I could then later on say that I want to take bill amount and give it a value. For that, I'm going to use the assignment operator. I know it looks like the equality operator or the equal operator, but it's not, it's the assignment operator. It's what we use to assign a value to a variable. In this case, I don't know, let's say I went to a nice restaurant, we got the bottle of wine, 167.18. Choosing random numbers here. So now I've got a value stored at that memory location that I've given the name bill amount. Now if I wanted to, I could actually do this all on just one line. You can combine those to assign a value immediately. Java is nice. Unlike C++, where when you create a variable and don't initialize a value for it, it just has the value of whatever happened to be in memory when you assigned the value. Like it could be a huge negative number in the millions. It doesn't, who knows? It's an unknown quantity. Java at least will default to setting stuff to 0 for you for the most part. But for here, we've got, sort of the proper way to do it. I'm going to initialize a value. Even if you initialize the value at 0, that's still a good idea to manually do that so that you know what the value is going to be. You don't have any unknown variables as you go into other things. So here we go. We have a thing with some sort of a number there. Now I might want to create another number. This is probably also going to be a double because it's going to have decimal points in it, and this is going to be my tip rate. I can decide how much I want to tip. Let's say that I'm a good person, but you may be thinking that this should be a whole number, but I almost always do the math this way. Like that's 15%, right? I'm doing the percent as a decimal number, but you can probably do it the other way. Just change the math when you're creating your expression. And in fact, we'll have to talk about operators here in a second, but for right now, I've got these two things. Now, you and me both know that what we need to do is multiply these numbers together. So I'll let you in on at least one operator before we start talking about operators. And then I want to display that amount. Now I could create a brand new variable to do that, to hold the answer and then display the answer. But since I'm only going to display the answer once, I could just get to actually printing out a value. So for me, I'm going to use my sout trick to do the system out.println. And I'm going to create a string. Tip amount, colon, space. Now I've got a string that's going to tell you what this number is, right? But I want to include a variable, or actually in this case, an expression, inside of that string. So how do I do it? Well, one of the ways that we can do it is by concatenating a string together, right? We can try to concatenate these things. And so concatenate is just a fancy word for putting things together. Now in this case, I'm using the plus operator. The plus operator, when you have a number on the left, is going to be addition. When you have a string on the left, it's going to be concatenation. And so I can then use the little math thing here to, and I'm going to put this in parentheses just so I'm sure that it happens first. We'll talk about order of operations here in a second. But I want bill amount, and I should be able to use code complete for this. By the way, I am going to not have enough room on my screen, so I'm going to drop that down a line. You will never have that problem so soon. I just have a massively large size font so you can actually see this. So bill amount, and I'm going to multiply that. Now that's the star operator, the asterisk is what we use for multiplication. And I want to multiply that by the tip rate. Done. I suppose if I wanted to be really fancy, I could put right there at the very end of the string a $sign. Now this isn't going to round so that it's to like the nearest hundredth or anything, but at the very least I will get a number that sort of makes sense. And we're going to let it run, let it run. Done building, and boom. Tip amount, $25.07. 8 cents, I guess, if you round up. Without worrying about how to do, format strings and stuff like that. Here we've got a pretty basic way to do it, and a way of creating variables and also printing out their values. So now, this is a pretty useless program. It's a pretty useless program because it only works for one particular bill, and I would have to rewrite the program for any other bill. That's not terribly helpful. So what I'd rather do is actually create a program that asks you for how much your bill was, right? This is something you could actually have on your smartphone, right? Like, hey, how much was the bill? And it tells you how much you should leave for tip. That would be useful. But for that, I actually have to be able to, and granted, this is all command line still, but you know, I actually have to be able to ask for it. So this is difficult in Java because Java is so strict about being object-oriented, right? So that bill amount, right, if I were to ask for it, so there's a system.out object that we're using currently, right? We know that we use that object and its methods, the methods that we can call on that object, there's a little button, we can say, hey, I'm going to send you something, push this button and you put it to the screen, okay? Print line or out object. There is also a system.in object. And what system.in is going to give you is a string of bytes that you then have to interpret to figure out what it's supposed to be. This is a little bit more tedious. And so Java created a utility that does it for you called a scanner. And so we could just use the scanner with the system in order to be able to interpret those things for us. So we know, is it going to be, we want to interpret it as a string, we want to interpret it as an integer, we want to interpret it as something else. But for that to work, we actually have to create an object in like our second video. This is not ideal. I mean, you know, if there were only another way, if there's only a Python class, right? But it's not, it's a Java class. And so for us to be able to get user input, we have to create an object. This isn't going to be terribly difficult, but a lot of it's going to feel like voodoo. However, it is great foreshadowing when we eventually get to you creating your own classes so you can create your own objects from those classes. And then it's like, oh, okay, I kind of now understand what we've been doing with scanners the entire time. So we have to do this. Now, scanner is strictly not part of the base Java language, right? It is one of the many Java utilities. And so in order to use it, we have to import java.util.scanner. That will allow us to import the code for that class, the scanner class, so that we can create an object of type scanner. You can start by just saying you want to import at the top line, and that works. And it's probably the better way. Some textbooks will actually have you do this. That star is a wildcard operator. It means you can put in any characters you want in place of that. What that effectively does is it imports every single Java utility there is. Well, at least all the ones that are in java.util, which are sort of the base ones. I am not sure if the compiler will go back, realize that you're not using most of them, and pull them so that you don't have an overly bloated program. Regardless, I don't like the idea of having to, you know, use a compiler optimization to do my work for me. Like in the same way, if I had one of those fancy cars that like could detect a collision coming and it brakes for you, I still wouldn't just keep my foot on the gas every time I approached a red light, figuring that, well, my car will just stop for me before I run into the stationary car in front. Like, no, I'm going to use the brakes still. Like, I want to have some control. So I would either put scanner here, or because I'm lazy and I'm using IntelliJ, by the way, the reason this is grayed out is because I'm not actually using the scanner. So it knows that that line is not needed. I'm going to get rid of that altogether. And then I am going to create my scanner object. So first thing I'm going to do at the very top of my program is I'm going to create a scanner object. And this is the way you would create an object. It's the way you're going to create objects later on when you create your own objects. We're going to create, kind of like we do with string, right? This is actually class, so the scanner class, I'm going to create this variable name. It's actually an object name. I'm going to call it keyboard because that's where the input's coming from. And I'm going to assign it to a new scanner. Now this is going to have parentheses. And the parentheses here mean that I'm actually going to call what we call a constructor on the scanner class. You don't have to worry about what they're called yet. At this point, you'll just know that this line is what you're going to use, right? Figure out the pattern, and eventually you'll figure out how it works. But I'll explain it as much as we can. Scanner, the constructor, is going to create a new scanner object. And then we will assign a reference to that new object with the name keyboard. So keyboard will be a reference to that new object. Now the scanner constructor, sometimes you'll create an object and you'll say, no, just the default is fine. I call this function and don't send it anything. The default is fine. Scanner, that particular constructor, would like to know, what do you want me to connect the scanner to? What do you want me to scan, in other words? And so for us, we're going to say we want it to scan the system.in. So this is going to be scanning the keyboard for input, and I'll show you how we sort of do that here in a second. But now I've got an object called keyboard that is, the type of that object is a scanner that I can use to get input and interpret input from a user. By the way, you'll notice that this is all in red, right? Why is that? It's because I didn't put in that import line. Like I said, I was lazy. A lot of times I wait until I actually use an object, and then once I've done using the object, because I know I'm in IntelliJ, it says cannot resolve symbol scanner. It's because I haven't imported it yet. If I right click, here, if I just click in the, don't right click, just click in the little red area, for me it is control return, no, option return. Ooh. Stop, don't generate. Option return. You'll see something up there that will be sort of what your key command is. It's probably going to be alt return on a PC, option return on a, or sorry, I guess alt enter on a PC, option return on Mac. But then that's going to pop up, hey, what class do you want to import? We're just going to use the standard Java utility. I don't know what these other scanners are, but that will be fine. And you'll notice that all that did was IntelliJ just added the line that I typed at the very beginning. If you know you're going to use it, you can just type in the line. If you want to be a little bit lazy, type it and then just use it to go and add the import line for you. But now I've got a scanner, which means bill amount should no longer be set to a particular value. What I can instead do is say keyboard dot next double. So the keyboard, that scanner object, has a bunch of different functions. In fact, I'm going to just type in, and you can see all of them. Next double, next byte. These ones just pull up individual stuff. Next float, next int, next long, next short, next big decimal, next big integer. These are for even bigger types. Next Boolean, next line. Next line, by the way, is going to return a string. So if you want to get a string, you'd think you would say next string, because that makes a lot of sense if we're keeping consistent. But no, it's next line. And that will grab all the way up to whenever somebody hits the new line character or the enter key. And so you've got all of those. In fact, the only type that doesn't have a next for it, a next method for it, is the character for some reason. You can't do next char. You can't interpret something as a character. It's a string or nothing. In practice, that's fine. A string of a single character is perfectly acceptable. But anyway, here I want next double because I want to interpret whatever you're about to type as a double. Now here we're going to, and it's a function call, so it needs parentheses at the end of it. It's a method technically because it belongs to an object, but we're fine. And so this will work. I can now grab an amount from the user and then give them the tip for 15%. I could probably also ask them for the tip rate or just display different tip rates, like this is the amount you pay for 10%, this is 15, this is 20. But for right now, we'll keep it simple. Basic input and output. So I'm going to hit run, and there's going to be one slightly annoying thing, but yeah, it'll be fine. Parsing the Java, running. I'm running two things at once on kind of an older laptop, so I don't see anything. And it doesn't even show that, I mean, I have a stop button active, right? Like I am currently running my program. And it's because my program is waiting for, it got to that keyboard next double. And when it sees that next double, it's like, okay, I'm waiting, keyboard, give me something. And until you press the enter key or return key, it's just gonna sit there and wait for you. So I have to say, yeah, no, our meal was $89.74. Hit return. There's your tip amount, although not looking pretty because I don't want to talk about format strings yet, right? But like, still, hey, that worked. The thing that was annoying was that I didn't get any input when I ran the program. So if you're going to get user input, I would recommend you do an S out with a little bit of a prompt. Enter amount of meal, colon, space. And in this case, I'm going to get rid of the print line and just do print. That way your input goes right next to the colon. That's a aesthetic thing. You can decide to do that or not. I'm not in charge of you. All right, I'm going to press run. And now when I run my program and it eventually builds, poor little machine. Enter the amount of meal. Oh, see, now I know what you want me to do. I see this, okay, $32.16. We went to Red Robin or something. There we go. I should owe $4.82-ish for the meal, for the tip, right? I've got some basic user input, some basic user output. If I were asking, enter your name, then I would want to do a string. I wouldn't call it bill amount, it'd have a better name than that, but keyboard.nextLine, and I would be able to grab that string. So yeah, that's how you do some basic printing out of your values, but also how you do some basic importing, how you get user input from users. That's going to make your programs a lot more dynamic going forward. Lastly, let's talk about some expressions and how we use expressions and operators to create more complex things. I already said that we aren't going to talk about the Boolean operators quite yet. We're going to wait till we get to branch statements for those. Likely, the bottom two you see here, increment and decrement, which just add one to a variable or subtract one from a variable. I'm going to wait until we get to loops for those because they're mostly associated with loops. Right now, let's just deal with some basic math, right? And a lot of these are going to seem really simple. The plus sign is for addition. The minus sign is for subtraction. You probably already knew that. I already mentioned to you that the star operator is for multiplication. I say star operator. Asterisk is really the name for it. So, what do you call it? Whatever you want to call it. The slash, specifically the / is what we use for division. Now, here's the thing with division. Division can be one of two types of division. In some languages, like Python, for instance, they have two different symbols for division, depending on what type of division you want to do, integer or floating point. Integer division is sometimes called floor division, whole number division, etc. But it has some interesting characteristics to it. So when you're using division and there's an integer on both sides of that operator, it's going to do the kind of division that you did when you were in 3rd grade, not 5th grade. Right? I actually don't know which grades these pop up in, but you know what I mean. Like, 2 goes into 5 how many times? Well, 2 goes into 5 2 times. So the answer is 2. Now, you all know that 5 divided by 2 is actually 2.5. But in 3rd grade, it wasn't. The answer was 2. That was the quotient. And there was a remainder of 1. Remember remainders? How quaint was that? Remainders. Well, the remainder from that operation is the modulus. So that is the remainder after division. So 5 divided by 2, if the 5 and 2 are both integers or integer literals, you're going to get the answer 2. If you do 5 modulo 2, you're going to get that's going to evaluate to 1 because that is the remainder after integer division. If you have a floating point on either side of that divide, then you're actually going to get 2.5. If you do 5.0 divided by 2, you're going to get 2.5, right? You're going to get the answer you expect. But a lot of times, integer division has its purposes, its uses. So the best way to kind of do this is with just a quick math test. If I have a number 5 and I say I want that number plus 2, that's 7. You already knew that. 5 minus 2, 3. 5 star 2, 10. Everything working like expected. 5 divided by 2, notice everything is an integer that has the value of 2, right? It's the simpler kind of division that had remainders to it. That means that 5 mod 2 is 1, right? It is the remainder after you do floor division or integer division. If I have floating point numbers or doubles, anything of floating point type, right, now this is going to be 2.5. It's exactly what you'd expect it to be. And so, yeah, with division, it sort of matters. With other stuff, it doesn't. If you multiply 2 doubles, you're always going to get a double, right? But if you multiply 2 integers, you're always going to get an integer. So it really kind of doesn't matter, and there can be some explicit conversions when needed. But yeah, regardless, it's division where you can kind of go from integers to suddenly needing a floating point. And if you only have integers, you're going to lose some information when you divide. The other thing about sort of these expressions is that they follow the order of operations. Now, in fact, every operator in Java is part of that order of operations, down from the assignment operator itself to that little dot operator that we use to show that we're actually, connecting, like it's this method is a member of this object, right? Every single operator that we use will be part of a larger order of operations. You could memorize them all. You could use parentheses if you're unsure. But at least for math expressions, you kind of already know the please excuse my dear Aunt Sally, right? Parentheses, anything in parentheses first, then exponents, then, this is where the please excuse my dear Aunt Sally sort of fails you. Math and division, right? My dear. You guys know that's a, what is it? A mnemonic to remember that please, parentheses, excuse, exponents, my dear, math, divide, Aunt Sally, add, subtract. So multiplication and division, you don't do all your multiplications first and then all your divisions. Multiplication and division happen at the same time, going from left to right. Same thing with adding and subtracting, because in reality, multiplication and division are actually kind of the same operation. It's just one's flipped. And then adding and subtracting are kind of the same. It's just you change the sign of one. But regardless, it's fine. Whether you think of it as adding a negative number or, they kind of go together. So you can do them left to right. So in this case, if my number is 5 and I have number plus 2 times 5, what is the result? The result is going to be 15, right? Because 2 times 5 is 10, and then I add 5 to it. Multiplication comes before addition, even though addition is to the left in this particular expression. And literally, that expression, you can just picture it like it goes poof and gets replaced by a 15, which is the value that we then assign to result. In reality, it gets shuffled and put into a register, which we then use to assign to result. But a poof, and you can picture it in your code, works the same as it gets replaced in a register. If I did this, I put parentheses around that number plus 2. Well, now it becomes much more clear. Oh, what I want to do is add the 5 and the 2 first. That's going to give me 7. And then I'm going to multiply that by 5, which is going to give me 35. So you can always use parentheses to be explicit about your operations. If you're ever unsure, adding additional parentheses isn't going to cost you anything. I have a weird theory that the more parentheses you have in your code, the more of a control freak you are, which is probably why I'm okay with adding a lot of parentheses, because I tend to add a lot of parentheses. Anyway, that's why I always drive when I go to lunch. The point being is you want to, be explicit about what it is you're doing. And just know that the order of operations for math do work in Java. All right. There's also a math class if you need to have something a little bit more. Unfortunately, to do exponents, you have to use the POW. There is no operator for exponents like there is in Python. So you're going to have to do like the POW function and send it 2 values. So this would be 5 squared. There's a square root that you can use. SQRT is the name for that. And there are also some constants. So like math.pi, all uppercase, that's a constant for pi, 3.1415. I can't remember how many decimal places it goes to by default in Java, but you can also just type in 3.14159. I've never had a reason to go beyond beyond 5 places for pi. Granted, you may be in a class that requires much more precision than that, but like, I'm just not that fancy. I've only ever needed 5. So anyway, those are some basic math operations and exponents and kind of how you put them together. And that should be it. That should be all you need for your assignment for this week. So yeah, some basic expressions, variables, the different types. I know it was kind of a lot, especially with user input and that scanner object, but again, that's just Java. As opposed to other languages where that's just a simple formula, it's something where you have to create a class, or you have to create an object of a different class and then call a method on that object because they want it to be very object-oriented. And that's something that we aren't going to get to for a few weeks. There are some versions of, there are some ways to teach computer science for these languages where you actually introduce objects much earlier. I kind of prefer this method where it's simpler to start, and then you kind of get this foreshadowing because you're using these objects. And then when we get to you creating your own custom classes, it makes more sense. But anyway, just part of the language. So hopefully this is all you need. If you have any questions, feel free to email me or send me a message in Canvas, and I will see you online.